Today's lesson is on direct and inverse variation, which is actually something that you have done in the past. We've talked about direct variation. And I forgot inverse. So this is just building on something that you did in 7th grade, a couple of times actually in 7th grade. So our learning goal, you will identify direct and inverse variation, D-E-N-T-I-F-Y, identify. Sorry, my handwriting is awful. And I will write and graph direct and inverse variation equations. So that's our learning goal. So first and foremost, we have to know what direct and inverse variation are. So starting off with direct variation, you may remember doing something that looked like this. Y equals kx, where your y is some number times your x, and we called that the constant of proportionality. We can also call it, well, if we write it like this, then we'd call that the slope. So we have a couple of different names for this number that you're multiplying the x. So direct variation in equation form looks something like this, where your constant of proportionality is a number that is not zero. It's a non-zero constant. And another way that you can look at this is we could divide each side by x, and you would have y over x equals k. So the ratio of y and x is a constant. If you were to graph direct variation, your direct variation graphs will always look like, put my axes on there, they will either look like this, or they will look like this. So they're linear, we have a constant slope, and they always go through the origin, because you'll notice if we're using this, slope-intercept form is usually y equals mx plus b, where b is your y-intercept. We don't have anything written here, so your y-intercept is always 0 for direct variation. So this is what your graphs will look like. This is what your equation should look like, some number times x, or you can write it as a ratio of y over x equals k. Now, if we're talking about inverse variation, it's kind of the opposite. So for inverse variation, instead of y equals kx, we have y equals k over x. And this is really going to be your first experience with having an x in the denominator when we're talking about graphing. And this makes our graphs look totally crazy. And again, k is not 0, because if k is 0, then we just get y equals 0 here. So for this one, another way to write this, you could say that k equals x times y. So in this case, the product of x and y is constant. So for direct, the ratio is constant. For the inverse, the product is constant. So we have the different forms. We also have graphs for inverse variation. And these ones are going to look pretty crazy compared to what you've seen. So our graphs will either look like this, or in the opposite quadrants, so like this. So something that I want you to notice is that this graph is actually never going to touch either of the axes, and we'll talk about why later on in this chapter. So if you see a graph that's a straight line that goes through 0, 0, that's direct variation. If you see these crazy curve graphs that are in opposite quadrants, that's going to be inverse variation. If your ratios are constant, that's direct. If your products are constant, that's inverse. So those are ways that you're going to identify. So we can do a couple of examples here. So if I have a table, we could say 1, 3 is a point, 2, 3 halves, 3, 1, 4, 3/4. So there's a table. And the first thing I want to do is I want to check and see if the ratios are constant, because that tends to be the easiest thing to do. That's 1/3. This, I'm going to skip this guy because it has a fraction. This ratio of x over y is 1/3. This ratio is 3 over 1. So these are obviously not going to be direct variation. So direct is out of the picture. So now I'm going to try inverse, and I'm going to look at the products. 1 times 3 equals 3. 2 times 3 halves equals 3. 3 times 1 equals 3. 4 times 3/4, because the 4's cancel, equals 3. So here, the product, x, y, is giving me a constant. In this case, my constant is 3. So this is inverse variation. And if I needed to come up with an equation for it, it's pretty easy. This is my basic equation, y equals k over x, and I just found that that constant is 3. So it would be y equals 3 over x. Okay, for this next one, we have another table with the points 1, 4, 2, 8, 3, 12, 4, 16. When you look at this, as my x goes up, my y goes up, and I can also see pretty quickly that I'm just multiplying my x's by 4, so I know this is going to be direct variation. The way to actually check that, though, is to look at the ratio of y over x. Excuse me. So y over x would be 4 over 1, which is 4. Here it would be 8 over 2, which is 4. The next one is 12 over 3, which is 4, and the next one is 16 over 4, which is 4. So in every single point that's given in our table, we end up getting the same number. We get that constant of 4. So that means this is direct variation, and that's because the ratio of y over x is constant. And again, if you think back to direct variation, we said we could look at the ratio, or we could write an equation as y equals kx for direct variation. Because my constant here is 4, I can also write the equation pretty quickly. Y equals 4x, and that's the equation for this situation. Besides being given tables, you might also be given equations. So for example, I could give you this. Three xy equals 6. If I want to know what type of equation I have here, I need to write it as y equals, remember, direct, y equals kx. Inverse, y equals k over x. So I need to see if this can be rewritten in either one of those forms. So if I need to get the y by itself, I would divide each side by 3x. So I have a y, and then 6 over 3 simplifies to 2 over 1. So y equals 2 over x, and that looks like indirect variation to me. So just from the equation, I can tell. You could also be given maybe something like this. 2y equals 5x plus 2. I can already see there's something suspicious there. I have a plus sign. If I really wanted to rewrite this, though, I could divide everything by 2. Y equals 5 halves x plus 1. Again, I have that guy sticking off on the end. If I have direct variation, I don't have anything here. Inverse variation has the x in the denominator, so that's totally different. So this is actually neither. So you might have some problems where instead of direct or inverse variation, you have neither. Now, of course, if I covered up that plus 1, if it was just 2y equals 5x, then I could write it as y equals 5/2 x, and that would be direct variation. But that wasn't the problem I was given. So the answer here is neither. Here is an example of when you're going to have to write an equation and graph an equation when you're just really given 1 point. The variable y varies directly with x. That right there is telling you this is direct variation, or y equals kx. When x equals 12, y equals -6. Write and graph a direct variation equation that relates x and y. So you see the word direct is in there twice, so we want to be using y equals kx here. We're relating x and y. What I can do, once I know the form it's supposed to take, I can take the pair that I'm given, x equals 12, y equals -6, put them into this basic form and solve for k. -6 equals k times 12. Divide each side by 12, and I get k equals -1/2. So my direct variation equation is going to be y equals -1/2 times x. I want to be careful because some of you may have seen that and thought, oh, it's going to be 2 or -2. And I can see why you would jump to that conclusion, but you just want to be super careful and maybe write it, actually write it out and make sure that you're not getting the reciprocal of what you should be, because sometimes it can be easy to think you're doing the mental math correctly and you're actually doing the opposite. So this is pretty easy to write the equation for, and then to graph it, we can all graph -1/2 x. I know it has to go through 0, 0, because it's a direct variation equation. And then I'm going to go down 1 over 2, down 1 over 2, and you might see, oh, x equals 12, y equals -6, I want to graph that, but that would be way off my page. I'm not going to deal with that. So that is what my graph will look like for this direct variation equation. All right, we just did direct variation, so now we're going to do an inverse variation graph. The variable y varies inversely with x. When x equals 2, y equals 5. Write an inverse variation equation that relates x and y. Remember, our inverse variation equations look like this. Y equals k over x. And a quick way to find k is k equals the product of x and y. So this one is actually a little bit easier to solve for k, but remember, this is what the final form should look like. So I'm going to take my x equals 2 and y equals 5 and put it in here to solve for k. So k equals 2 times 5. So k is going to be 10. So my inverse variation equation will be y equals 10 over x. And now I need to graph it. So this is where things get just a little bit crazy. So remember, we want to pick a couple of points. Whenever we're making a graph and we don't know what it's supposed to look like, we always start off by making a table of values. Because I'm graphing this, 10 over x, I'm not going to want to pick, all of my normal points where I would just pick like 0, 1, and 2. Those aren't necessarily the points I want to pick. Instead, I'm going to pick maybe 10, 5, and then 1, and then also -5, -10, -1, that sort of thing. So let's look at these. If x is -10, 10 divided by -10 is -1. If x is -5, 10 divided by -5 is going to give me -2. If x is -1, 10 over -1 is -10. So you can see as these x's go down, well actually as my x's get closer to 0, my y's get further from 0. If I put in 0 for x, I get undefined because I'm not allowed to divide 10 by 0. Remember, 10 divided by 0 is undefined. Never allowed to happen. And then I can try some positive numbers and see what happens. So 10 divided by 1 is 10. 10 divided by this 5 is 2, and 10 divided by 10 is 1. So now as my x's are increasing, my y's are decreasing. So if I wanted to graph this, remember, just keep in the back of your mind, that my inverse variation graphs look something like this. So they basically have two branches. If I put in negative 10, 7, 8, 9, 10, 10. Sorry, I should have had this ready to go. I'm gonna run out of room. If I graph negative 10, 1, my graph is going to be right here, or my point will be right here. Negative 5, negative 2 is down here. Negative 1, negative 10 is going to be all the way down here. I could have also, like if I put in negative 2, I get 5. So somewhere along there. Basically, I'm going to have a curve that looks something like this. This graph is never, ever, ever going to be able to touch my x-axis, because that would mean that 10 divided by something gives me 0. And there is no number that I can divide 10 by to get 0, keeping this in mind. When I divide 10 by 0, I get undefined. I'm also going to get closer and closer to the y-axis, but I'm never going to be able to touch it, because if I put in 0 for x, I get undefined. 0 is not allowed to go into x. So I can never touch the y-axis, which is when x equals 0. If I graph these points, 1, 10 is going to be up here in my table. 5, 2 is going to be right about here. And then 10, 1 is going to be here. I'm going to get a mirroring curve over on this side with the same situation. I can never touch the x or the y axes. So this is what your your inverse variation graph is going to look like. If you think about it, if I put in a half, 10 divided by 1/2 is actually 10 times 2, which is 20. If I divided by a third, I would end up with 30. If I divided by a fourth, I would end up with 50. So as my fraction gets smaller and smaller and smaller, for x, my y value is getting bigger and bigger and bigger. So that's why the graph takes this shape, and then the opposite happens, with the negative side. So you can pick a couple of points, plug them in, get a graph that makes sense, but just remember your inverse variation graphs always have these two branches that never touch, and they never touch the x-axis or the y-axis when they're in this form, y equals k over x. And, because I almost forgot to talk about it, your favorite thing ever, the domain and range. So remember, your domain is everything that x is, your range is all of your y's, and there's actually a super easy way to write this. We just said that x can never be 0, so that's all I have to say. X is not equal to 0. For a range, y can be anything up here, anything down here, it just can't equal 0, so my range is y is not equal to 0. So that's pretty easy. I could also say all real numbers except 0. This is how I like to write it though, because it's pretty straightforward. Okay, so finally we're going to talk just a little bit about when you might have inverse variation, because it's kind of a different idea than what you've seen before. Inverse variation is going to happen when one of your values goes up that causes the other one to go down. For example, if you are maybe renting a house for the weekend and it costs $1,000. If you rent that house, let's say you have people and price per person. If just you rent that house by yourself, you're going to pay $1,000. If you and a friend both rent the house, you're each going to pay $500. Together, you still have to pay that $1,000, but per person, the price is going down. For 3 people, it would be $333-ish. For 4 people, it would be $250. So you can see, as X, the number of people renting the house increases, the amount that you pay per person decreases, but that product of X and Y stays constant the entire time. This also happens when you're talking about maybe your speed and how long it takes to do something. So the faster you go, the less time it takes. So that would be another example of inverse variation. Direct variation is like, well, it costs $5 per pound. So this is inverse. For direct, it would be as your X increases, your Y also increases. So if I buy more, I have to pay more, that sort of idea. So those are the different things. If you take a peek in your book, there are some other examples, but I think that gives you a pretty good idea. If one goes up and the other goes down, that's inverse. If they go up together, that's direct. So your homework for tonight is on page 547, and you will do numbers 1, 2, 4 through 16 even, 23, 26 through 38, and 39 to 42. It looks like a lot, but remember those first 2 problems were super quick. You just had to look at the ratios of the products to see. So there is your assignment, and good luck.